Hey buddies, welcome back to VinVout-io. I'm Deva. How about this? A beautiful RGB dome. The RGB LEDs alter power on each of the channels, that is the red, blue and green, to make a specific color mix. For this purpose, we can use a PWM, the pulse width modulation technique. With this technique, we can control the brightness of each of the colors and make our desired color. Easy, right? But we are using a small microcontroller to make things small. But the actual problem is the ATtiny85 have only 2 PWM supported pins. When I first uploaded the code, it did work, but it wasn't satisfying for me because the colors were always flickering and I didn't like it. So I did some research and found that we can implement software PWM on our ATtiny85. It's a technique for generating PWM output signals without the need for an actual PWM hardware module within your microcontroller. So now we have the color mixing or the gradient changing so smoothly, and it's so beautiful. I wanted to add additional features like stay on a specific color when we give an input, or maybe like an RGB mood lamp. It will be cool to change the colors just by tapping, and maybe a piezo can be handy. Attach to the piezo and upload the code, and didn't work like I expected. It wouldn't change color. It was because of a small bug in my code. First of all, the RGB color mixing code was inside a for loop, so the microcontroller, when I give the input, couldn't do anything. I changed the code, put each of the colors as a function call and called them here in the void loop. So when I first give the input, it will go through these, and whenever I give another input, it can break easily from these calls. So that's how it works. Now upload the code. Oh wait, here I am using an Arduino as ISP programmer to upload the code. Now put your ATtiny back into the circuit and connect a 12 volt adapter and enjoy it. This is our setup, and here we have the brain, the microcontroller, the ATtiny85, and this is our RGB LED, and we have connected 3 resistors right here, and I have also connected 1 mega ohm resistor to the microcontroller as well as to the piezo and to the ground. This part right here is actually just for powering it from a 12 volt DC supply rather than always taking the input from a battery. So I think because I will be using it all the time, not just for showing this video. That's all the parts we need. I'll give the schematics.